Hi everyone. This video is going to help you learn how to write parametric equations from different types of information. So this first problem we're going to do is a parametric equation based upon data, so based upon just some endpoints. It's a segment, so hopefully as we create the segment, it'll be kind of obvious how this is going to work. So I'm going to start by plotting the 2 points. So we're going to have these endpoints at -6, 1, 2, 3, 4, 5, 6, 1. And we have the point 4, 6. Okay, so we are trying to create a segment, and it depends on which direction we want it to go in. So I kind of drew the line like this, but realistically, we don't know which direction it's going. So we could technically start at 4, 6 and go down to -6, 1. Okay, so we want this line to graph over the time interval 0 to 5. So that means we want um, this first point at time equals 0 to start with x equal to -6 and y being 1. And then at time 5, we want the point to be at 4, 6. Oops. So we could fill in some values in the middle. I am going to do that to help us make sense of this. So if I'm going to go from -6 to 4, well, the y's are pretty obvious what we're trying to do. So the y's I can clearly go up by ones. So 1, 2, 3, 4, 5, and 6. And it looks like these probably need to go up by 2. So like a -4, -2, 0, and 2. And if you couldn't do this because the numbers we picked didn't fit nicely in the window, you wouldn't even need to fill them in. Is kind of just extra to help you see what's going on. Okay, so we need to make two different equations. We need to make an x equation in terms of t and a y equation in terms of t. So I find it kind of helps me if I will try to cover up the data. Okay, so we're just going to look at x in terms of t here. So when I look at this, I see that the x's are going up by 2s, the y's are going up by 1s, and the intercept is -6. So when I go to write an equation for this, it would just be x equals 2t minus 6. So like a t-intercept there, if you will. Or sorry, not t, x-intercept, I guess. Okay, so let's put some numbers in just to make sure this is correct. So if I put 5 in for t, I get 4. If I put 3 in for t, I get 0. So that works. So that's my x equation. And now I'm going to do the y version here. So I'm going to do y's in terms of t. And my y's go up by 1s as my t's go up by 1. So I have a slope there of 1. And I have a y-intercept here of 1. So when I write this equation, I have y equals t plus 1. And again, let's make sure that's making sense. So I put, let's say 2 in for t, I get 3. 5 in for t, I get 6. Okay, pretty straightforward. Um, this is probably the best way to do it. If I had changed the time in there, so let's say I made this go from like 0 to 10 as opposed to 0 to 5, then that would change the slopes a little bit because the t's would be going up by 2s as well if we did that. So that would change it a little bit, but it would still be, you would still just do the exact same thing. You'd still just look at the t's and the x's and then the t's and the y's. Okay, question 2 now. I'm giving you an equation in like a rectangular equation, and we have a specific domain we want it to fit into, and we want to come up with parametrics, so an x and a y. So if I were to graph this, let's see how good of a job I can do with this with my mouse pad here. So when x is equal to -1, I get 6 for, let's try that again. So you know what I did is I put these numbers in the wrong spots. So this should be a -1. So my domain is the x's here, right? So my x's, not my t's, are going from 0. Sorry, from -1 to 2. So let's make that make sense here. again. Okay, sorry about that. So when x is -1, I get 6 here. When x is 0, I get y is 5. X is +1, I get 6 again. X is +2, I get 9. So this isn't going to fit really well on here. I think I'm going to go by 2s on my y's here. So 2, 4, 6, 8. Okay, so -1 is at 6, 0 is at 5, 1 is back at 6, and 2 is at 9. You guys know how to graph. So here is my partial parabola. So now I need to fill in some times. I didn't tell you what times to use, so you can usually make that up. It tends to make the most sense when we do times starting at 0, although technically we can use whatever numbers we want. But we're going to start at 0 because it'll be good practice for us. So 0, 1, 2, and 3. Okay, so the x equation should be pretty easy here. So I've got my t's are going up by 1s and my x's are going up by 1s, and my intercept is -1. So it appears to me that my x equation will be t minus 1. Okay, so that's because my x equation. Now, to figure out what the y equation is equal to, you have a couple of options on how to do this. One would be to kind of ignore completely what's going on in the middle here and just compare the t's and the y's. And when I look at this, I can see that this is behaving like a normal parabola because I'm going down 1 and then up 1 and then up 3. So I see the normal parabola behavior where 1 comma 5 is my vertex. Okay, so if you remember how to do vertex form of a parabola, so this would be y minus, excuse me, y minus 5 equals, now we're in terms of t instead of x, t minus 1 squared. Okay, so this is my y equation. I just add the 5 to the other side. So I have t minus 1 squared plus 5. Okay, so this is by doing the problem without even using the original rectangular. So if you didn't have this rectangular, this is really what you'd need to do. But if you have the rectangular equation already, which is here, you could take, which you can see this is actually what it turned out to be. You take the t minus 1, you take what you got for x, you solve it, or I'm sorry, substitute it in for x into the original rectangular equation. So t minus 1 goes in for x here, and that's how you get t minus 1 squared plus 5. So this second version in blue is definitely easier, but it's only easier if you already have the rectangular equation. If you don't have the rectangular equation, then you still have to create that and do the substitution anyways. So just depends on what you have and what you like best. All right, so now I have this, did it again, this problem where I want you to do this 2 different ways. So you can kind of decide which one works best for you. But we have a domain, that's my x values, not my t values. My domain from 0 to 2. Okay, so there's my domain filled in. I'm gonna go ahead and graph the rectangular, and I do need to change my bounds so that they make sense here. So let's say that if x is 0, y is 0. If x is 1, y is 1. And if x is 2, 2 to the 6th would be 64. Hope I'm right there. Yeah. So clearly that's not going to fit on this window. So we're just going to kind of fake it a little bit here. So I've got 0, 0, 1, 1, 2, 64. So way up here someplace. Okay. So the easiest way to do these problems, in my opinion, is to just make, especially with time starting at 0 like this, or x starting at 0, is to just make it be time and x start with the same value. Sorry, I'm just copying this over here so I have it twice. So one thing I could do is literally let my t's go from 0 to 2 as well. So put 0, 1, and 2 in here, which means that my x equation is equal to t, and my y equation is just equal to t to the sixth. So that is certainly the easiest version. But if that wasn't what I wanted you to do, I wanted you to start someplace different, then you'd have to change this up a little bit. So let's say I want it to start at, I don't know, 4. Okay. So t starts at 4. It would still be easiest if I go up by ones. So if t starts at 4, then it would be 4, 5, and 6, which means that the x equation has a slope of 1 and a intercept. So it's not really an intercept, so we have to think about this going backwards, right? So if you have the point, let's see, I'll actually graph these so you guys can see what I'm talking about here. So let me erase this. So if I have the point 4, 0, 5, 1, 6, 2, right? So there it is. Terrible line, but you get the point. This point would have an x, an intercept over here of -4. So this becomes t minus 4. And then I can substitute t minus 4 in for x in the original problem. So it looks like this. Now, something I didn't talk to you about that I should, and I didn't do it on the last problem either, so maybe we'll go back and talk about it, is that I don't want to graph, um, like I don't want my t's to go on forever. I only want this little chunk that's going to give us these points. So then you have to give a domain restriction on the t as well. So you'd have to say on this problem that t is actually from 4 to 6 so that it makes sense, right? Check, substitute 4 in, substitute 6 in, make sure you're getting the answers you're supposed to get. And then t over here is going from 0 to 2. And even that last problem on the last screen, we should really make sure we talk about the t's as well. So if I go back to this one for a second, my t's on this problem, so my bounds here go from 0 to 3. So you do want to make sure you include that in your answer. All right, I hope that makes sense. Ask your teacher or email your teacher if you have any questions.